Now we will start with the last topic of linear algebra, inner product spaces.
अभी हम पूरा क्वाड्रेटिक फॉर्म्स में रहते हैं ना.
हाँ वो इसी के बाद आएगा इनर प्रोडक्ट स्पेसेस में बाइलिनियर क्वाड्रेटिक. So firstly we will see the definition of inner product space. Let V be a vector space over field F. Then V is inner product space under an inner product map V cross V to F which satisfy the following conditions. First condition, inner product of alpha u1 plus beta u2 comma v. So इसमें क्या होगा, इसको ओपन करो, alpha u1 comma v inner product plus beta u2 comma v inner product. So from first coordinate scalar will come outside as it is, alpha inner product of u1 comma v plus beta inner product of u2 comma v. For all alpha and beta are scalar and u1, u2 and v are vectors from the vector space V. So this is inner product is linear in first coordinate. This is first coordinate na? It is linear in first coordinate. Second property, inner product of u comma v is equals to inner product of v comma u conjugate for all u comma v belongs to vector space V. Third property, inner product of u with u itself is greater than equal to 0 or equal to 0 if and only if vector u is 0. Then only inner product of u with u will be equal to 0. And inner product of u comma u is greater than equal to 0 means inner product is non-negative. Then we will say that vector space V with respect to the inner product is called inner product space. Now another property, inner product of u comma alpha v1 plus beta v2. Now I can use property 2 and I can write it as alpha v1 plus beta v2 comma u का conjugate. I can use property second. So from here it will be alpha v1 comma u conjugate plus beta v2 comma u conjugate. So I need to take this scalar outside and a conjugate sign is there, so it will be alpha conjugate v1 comma u plus beta conjugate v2 comma u conjugate. Now again apply property second. So this will become alpha conjugate u comma v1 plus beta conjugate u comma v2. So in short, I was telling that whenever I need to take out the scalar from this second coordinate, when I want to take out the scalar outside from this second coordinate, then it will come as a conjugate. Inner product is conjugate linear in its second coordinate. Is this clear?
Yes, ma'am.
Okay. Now some examples. V equal to C01 means continuous functions. Second type will be M n cross n matrices over F, and third type will be tuple form. V equal to C01 means inner product will be a map like this: V cross V2 field F. I am taking field F as real numbers. So this map will be C01 cross C01 to real numbers, and inner product is defined as F comma G is equals to integration from 0 to 1 F G conjugate dx. Now I need to verify that this is a inner product space. So first property, alpha f1 plus beta f2 comma g means I am taking alpha beta scalars from field R and f1 f2 g. These are my functions which belongs to C01. So apply this inner product, integration 0 to 1 alpha f1 plus beta f2 g conjugate dx. Now this will be integration 0 to 1 alpha f1 g bar dx plus 0 to 1 beta f2 g conjugate dx. Now I can take this scalar outside this integration sign. Again apply the definition of given inner product. It will be alpha inner product of f1 with g plus beta inner product of f2 with g. So first property is verified. Now second property, inner product of g comma f conjugate. It will be 0 to 1 g f bar whole conjugate dx. I have only applied this inner product definition. So 0 to 1 g bar f dx, because f का 2 बार कॉन्जुगेट लेने पर हमारे पास f वापस से आएगा. So this will be 0 to 1 f g conjugate dx. So this will be again f comma g inner product. Second property is also verified. Now let us verify third property. Inner product of f comma f, integration 0 to 1 f bar dx. What will be this? F into f bar? F
S square.
mod f square, and this is clearly greater than equal to 0. So this property is also verified, and we know that this inner product will be equal to 0 implies integration 0 to 1 mod f square dx is 0. So this will imply that f will be, or I can say mod f square is 0. This implies f is 0. This is if and only if result. Third property is also verified. Therefore, v comma inner product of f comma g is an inner product space. Next example, v equal to m cross n. It was m cross n. Inner product of a comma b is defined as trace of v theta a. This is standard inner product. Try this and tell me whether it will be an inner product space or not. You need to verify the three properties. So let us check the first property. Alpha a1 plus beta a2 means alpha beta are my scalars a1 a2 and v. This belongs to v, means they are matrices. So apply this definition. It will be trace of b theta. Definition is clear na?
That is conjugate transpose, no?
Transpose conjugate.
Transpose conjugate.
So this will be b theta alpha a1 plus beta a2. Now trace of b theta alpha a1 plus b theta beta a2. Now I have told you that trace is a linear transformation. Na? So trace of b theta alpha a plus trace of b theta beta a2. Now as trace is a linear transformation, I can take this alpha scalar outside. Again apply the definition of inner product. This will be alpha inner product of a1 with b plus beta inner product of a2 with b. So first property is verified. Now second property. I need to verify inner product of a comma b is equals to inner product of b comma a conjugate. Inner product of a comma b is trace of b theta a. Now I can write it as trace of a theta b whole theta, because a theta b theta is b theta a. This is a property of this transpose conjugate. So this will be trace of a theta b whole conjugate. This will be inner product of b comma a का conjugate. Second property is also verified. Now let us verify third property. Inner product of a comma a is equals to trace of a theta a. So what will be the trace of a theta a? I will take a small example. If matrix is of order 2, what will be a theta? A
It is A11, A12, whichever, or with minus sign conjugate, but
conjugate ले
we
लेंगे.
have conjugate ले लेते हैं.
Okay. Now product of a theta a. This will be a11 conjugate a11 plus a21 conjugate a21 trace of a theta a will be a11 conjugate a11 plus a21 conjugate a21 plus a12 conjugate a12 a22 conjugate a22, and I can apply this a11 conjugate into a11 is mod of A11 square. So trace will be in general summation mod of Aij square, and clearly it will be greater than equal to 0. And if I need to check inner product of A comma A is 0, means this has to be 0 and this will be 0 if mod of Aij square is 0. This means that Aij is 0. If all the entries are 0, then it will be a 0 matrix now. So third property is also verified. This is if and only if. Therefore, V with respect to this inner product is an inner product space. Next example. B equal to F and F. Now in the form of a tuple. U1, U2, so on till UN n cross n such that Ui belongs to field and inner product is defined as U comma V is equals to trace of V theta U. Trace of V theta U. If you will take any V vector V1, V2, so on till Vn. ठीक है, so V theta क्या हो जाएगा बताओ. V theta will be
B1 bar, B2 bar in a row. Sorry.
रो ही होगा, ट्रांसपोज लेंगे ना.
Transpose करेंगे.
V theta U will be V1 bar, V2 bar, V1 begin bar and U1, U2 so on till UN. So this will be trace only. V1 bar U1 plus so this will be also a inner product space. Okay. You can verify it yourself, it is easy. Okay. Verify that it is a inner product space. Now next definition is norm of a vector. Let V be a vector space over F. Please mute yourself. Norm of vector is denoted by norm V. It has some properties. It will be a map from vector space V to real numbers. So first property is norm of V is greater than equal to 0. It is equal to 0 if and only if V is 0. This is non-negativity property. Norm of alpha V is equals to mod alpha norm V. For all alpha belongs to F, it is better to take field F only, because field can be real numbers or complex numbers. V belongs to V. This is scalar property. Now triangle inequality property. Norm of U plus V less than equal to norm U plus norm V for all U comma V belongs to vector space V. Triangle inequality property. Vector space V with the norm is known as normed vector space or normed linear space. Let us see some examples of norm. V is equals to C infinity 0, 1. What does this set mean?
Infinitely differentiable function, continuous function, sorry, over 0, 1.
Continuous भी होंगे और infinitely times differentiable होंगे over this interval 0, 1. Norm is defined as supremum x belongs to 0, 1 mod of f dash x. So first property, norm of f is greater than equal to 0. If I take f as 1, then f dash x will be 0. So norm of f is supremum x belongs to 0, 1 mod of f dash x. It is 0. So I am getting norm of f as 0, but f is non-zero. Norm of f is 0 if and only if f is 0. So first condition is not defined, na? It is violated. Means norm is not well defined. Therefore, it is not a norm linear space. If norm is defined like this, supremum x belongs to 0, 1 mod of fx, then first property, norm of f greater than equal to 0. Norm of f is supremum x belongs to 0, 1 mod of fx. This is clearly greater than equal to 0. And norm of f is 0 means supremum x belongs to 0, 1 mod of fx is 0. This means mod of fx is 0, and this is possible only if fx is 0. So this is if and only if first property is satisfied. Now second property, scalar property. Norm of alpha f is supremum x belongs to 0, 1 mod of alpha fx. Now here I can apply modulus property, na? Mod alpha mod of fx. Now this mod alpha can be taken outside because it does not depend on x. And this is norm of f. The second property is also satisfied. Now third property. Third property is norm of f plus g is less than equal to norm f plus norm g. Triangle inequality property. Supremum x belongs to 0, 1 mod of fx plus gx. So here I can simply apply triangle inequality property. Supremum x belongs to 0, 1 mod of fx plus supremum x belongs to 0, 1 mod of gx. This is norm f, this is norm g. So all the properties are verified. Therefore, in a vector space V with respect to the given norm is a normed vector space. Next example. V equal to M 2 cross 2 over real. Norm of A is minimum of I comma j mod of I comma mod of A ij. Now tell me whether it is a normed linear space or not.
सेटिस्फाई तो कर रही है, जैसे फर्स्ट है उसमें अगर हम मिनिमम जो मैट्रिक्स ऐसे चूज कर ले, जीरो ही तभी आएगा ना जब ए आई जी कोई जीरो होगा, तो फर्स्ट प्रॉपर्टी तो वैसे ही शो कर रही है।
अगर A इक्वल टू आइडेंटिटी मैट्रिक्स ही ले लें,
तो मिनिमम जीरो तभी होगा जब जीरो होगा।
minimum of all these entries is 0.
Zero.
But matrix A is not 0. So it is not a normed linear space.
अच्छा ठीक है, मैं पर्टिकुलर LAIG को ही ले रही थी। ओके ठीक है।
नहीं, कोई एग्जांपल लेके डिस्कार्ड कर सकते हैं ना कि भाई वो नहीं सेटिस्फाई हो रहा।
नहीं मैं एक्चुअली एलिमेंट को कह रही थी कि AIJ मिनिमम तभी 0 होगा जब AIJ 0 होगा ना, मैट्रिक्स को लिखना। ठीक है।
वो फिर पर्टिकुलर केस हो गया कि सिर्फ 0 मैट्रिक्स के लिए।
ठीक है, फिर आगे तो चेक करने की जरूरत ही नहीं है।
नहीं, फर्स्ट प्रॉपर्टी से ही पता लग गया। norm of A is equals to rank of A. Check this.
इसमें तो फर्स्ट प्रॉपर्टी सेटिस्फाई होगी क्योंकि रैंक है 0 तभी होगी अगर एक 0 मैट्रिक्स होगी। फर्स्ट प्रॉपर्टी तो सेटिस्फाई है। सेकंड कैन ऑल्सो बट अल्फा टाइम्स रैंक तो नहीं होगी, तो सेकंड नहीं सेटिस्फाई होगी इसमें।
norm of alpha A means
that
rank
is not
of alpha
equal to
A.
alpha times rank of A.
Reason?
Simple as that is a multiplier only, no? Simple. So it will not be alpha times of rank of A.
For example, if I take A matrix as identity matrix only, then rank of A is 2.
2.
If I take alpha as 2,
the rank will not be 4, it will be 2 only.
Matrix 2A rank will also be 2 only. So this is 2 and this is 2 into 2. Not satisfied. This is not a norm linear space. Consider the real vector space V of polynomials of degree less than or equal to D for P belongs to V, means P is a polynomial. Norm is defined as maximum mod of P0 mod of P dash 0 so on till mod of Pk 0, where Pi0 is the ith derivative of P evaluated at 0, then norm Pk. This defines a norm on V if and only if first option k is greater than equal to d minus 1. Second option, k is less than d. Third option, k is greater than equal to d. Fourth option, k is less than d minus 1.
नहीं क्लियर हो रहा इसको कैसे करेंगे। अगर हमने सेकंड डिग्री का ही पॉलिनोमियल ले लिया 1 + x + x स्क्वायर, so norm of this is maximum of, then norm will come as 2, then
1 + x + x को I mean इतना कॉम्प्लिकेटेड लेने की क्या जरूरत है, सिंपल ले लो।
1 ले लें।
जैसे k क्या ले रहे हो?
मतलब मैंने अगर मैं D2 लेती हूँ तो K फिर ऑटोमेटिकली 2 ही आएगा।
नहीं, डिफरेंट एग्जांपल्स लो ना इन ऑप्शंस के अकॉर्डिंगली, कि कभी k लेस देन d लो, कभी k ग्रेटर देन d लो।
अच्छा,
जैसे अगर
K greater than D-1, अगर D2 है तो K can be 2 also। फर्स्ट अगर फर्स्ट वाला ही देखें तो K greater than D-1, तो K भी 2 हो जाएगा, उसमें D भी 2 हो जाएगा, तो उसके अकॉर्डिंगली तो जो नॉर्म आएगा वो 2 आएगा, मैक्सिमम ऑफ दिस।
जैसे अगर मैं k को 1 ले लूँ, d 2 ले लूँ, k इज लेस देन d, पहले ऑप्शन 1 देखते हैं, ठीक है।
ठीक है।
सो norm p will be, p belongs to v,
Yes,
polynomial
1
of
plus
degree
x.
less than or equal to d means
plus
x,
x plus x square.
सिंपली अगर x स्क्वायर ही ले लूँ तो भी ठीक है,
ठीक है।
ठीक है। सो norm of x square will be maximum of mod of p 0 0 and mod of p dash 0 because
अगेन 0
k equal to 1 तक ही।
0
But you can clearly see that x square is non-zero ना,
so it will not satisfy.
So by this option 2 is discarded. And if I take, and also from here if I take another example, k equal to 1 and d3, fourth option, 1 less than d minus 1 to satisfy हो रहा है। So here polynomial p will be x cube, again norm of x cube, this will be
again 0
but x cube is non-zero,
Hmm.
so option 4 is also discarded.
k greater than d, k greater than d minus 1 ले लेते हैं पहले।
k greater than d minus 1 means
d को अगर हम 1 लें तो k भी 1 ले सकते हैं,
एक सेकेंड,
या 0 ग्रेटर देन और इक्वल टू 0, k 0 ले सकते हैं फिर,
या फिर ऐसे देखो ना, k ग्रेटर देन इक्वल d माइनस 1 मीन्स k इक्वल टू d माइनस 1, यही वाले एग्जाम्पल से हो जाएगा। इफ k इज 1 देन d माइनस 1 इज 1 only,
1 only.
then also first option is also discarded from here only. So first, second and fourth are discarded, so answer is option third.
So, अगर हम k greater than d लें तो d लिया हमने x square और k हो जाएगा x cube for example, then in that case
So polynomial will be
0 0
norm of x square, this will be maximum of p0, p dash 0, p double dash 0 and p triple dash 0 na, so maximum of p0 0,
0
p dash 0 0, but p double dash will be
2
2, so maximum will be 2.
2
Also x square is non-zero, so ऐसे देख सकते हो कि norm of x square equal to 0 if and only if x equal to 0, ये दिखाना था। बट अगर इसकी नेगेशन के वे में सोचूं, norm of x square is not equal to 0 if and only if x square is not equal to 0.
ठीक है।
So option 3 is satisfied. Now next definition. Let V be an inner product space. Define norm V. Norm V also denotes the length of the norm. Now length means distance only, and distance is written by square root and norm V, inner product of V with V itself. It satisfies all the properties of normed linear space. Now every inner product space is normed linear space, but converse is not true. Now I will discuss an example to find length of the norm. If I take V as M 2 cross 3 over C, field is also C, and matrix A is 1 iota, iota, 1, 1 iota, and I am defining inner product as trace of V theta A. Now I need to find norm of A, means square root inner product of A comma A. This will be under root trace of A theta A. Firstly, we will find A theta. It will be transpose conjugate 1 minus iota 1 minus iota 1 minus iota. Then A theta A. A is 1 iota, iota 1, 1 iota. So this will be, this is 3 cross 2, this is 2 cross 3. Two zero two 0 2 0 2 0 2. So trace will be 2 plus 2 plus 2 6. Is this clear?
Yes, sir.
Next is Cauchy-Squar's inequality. Let V be an inner product space over field F, then for every U comma V in V, mod of inner product of U comma V is less than equal to norm U, norm V. Furthermore, equality holds if and only if U and V are linearly dependent, means one is scalar multiple of other. Now next definition is orthogonal set. Do you remember the definition of orthogonal set or orthogonal vectors?
Yes. Dot product is 0.
let V be an inner product space over field F. A vector U belongs to inner product space V is said to be orthogonal to another vector belonging to inner product space V if inner product of U comma V is 0. For example, if U is equals to A comma B, V is equals to C comma D. This belongs to C square. Then inner product of U comma V is AC conjugate plus BD conjugate. Now I need to check vectors x equal to 3 comma 5 and y equal to 5 iota comma minus 3 iota are orthogonal or not. Simply inner product of x comma y. So this will be 3 into AC conjugate. A is 3 and C conjugate means minus 5 iota plus B D conjugate 3 iota. So this will be 0. This means that vectors x and y are orthogonal to each other. Now what do you understand by the definition of orthonormal set?
Sum is one.
There will be two properties. Firstly, vectors will be orthogonal and norm will be 1. This definition was of orthogonal vectors. Now I am writing a definition for orthogonal set. A subset X of V is said to be an orthogonal set if for any x comma y belongs to x, inner product of x comma y is 0 whenever x is not equal to y. Means these vectors should be distinct. Now next definition is orthonormal set. A subset X of V is called an orthonormal set if first property norm of x is equals to 1 for all x belongs to x, and second property inner product of x comma y is 0 for x comma y belonging to this subset of inner product space V whenever x is not equal to y. Note, every orthonormal set is orthogonal set but converse need not be true. Let us see some more examples. So tell me whether it is orthogonal, orthonormal, or both.
Both.
Hmm. Now a counter example for this. So this is orthogonal na? Inner product of every two vectors is 0.
Yes.
But norm is not equal to 1 na? Norm is 2 in this case, 2 in this case, and 1 in this case. I mean,
Yes. Yes. Clear.
so it is not orthonormal. Means every orthonormal set can be orthogonal, but converse is not true. Orthogonal set need not be orthonormal. So tell me whether it is orthogonal, orthonormal. Hmm.
It is both.
Hmm. Next example. Hmm.
Neither orthogonal nor orthonormal.
Hmm. Dot product is not equal to 0, and norm of this is not equal to 1. Let Rn n greater than equal to 2 be equipped with standard inner product. Let v1, v2 so on till vn be n column vectors forming an orthonormal basis
Third option, A transpose equal to A inverse.
Reason?
Every orthonormal is orthogonal also. So for orthogonality property, A transpose is equal to A inverse.
Or you can say like this, that A is a n cross n matrix formed by the column vectors v1, v2 up to vn. And these vectors were orthonormal. So in short, A is a orthogonal matrix only. So that's why option 3 is correct. So next, S is orthogonal, which contains all non-zero vectors, is independent. For example, if I take an example of 0, 0, 1, 0. So clearly it is orthogonal, but not linearly independent, because it contains a vector 0, 0. So a set of non-zero orthogonal vectors is are linearly independent. Every orthonormal set is linearly independent, because every orthonormal set is orthogonal and a set of non-zero orthogonal vectors is Li. Converse of both the above statements is not true. For example, this set is Li. Is it orthogonal or orthonormal, or neither of them?
Sorry, I'm not. What's the question?
It is Li. I am asking whether this set S is orthogonal, orthonormal, or neither of them, because I am showing that converse of this statement
It
is
is
not
not
true.
orthogonal and non-orthonormal.
I can say
Neither orthogonal nor orthonormal.
means converse of both the above statements is not true. Now we will learn a process by which I can form orthogonal vectors. Gram Schmidt orthonormalization or orthogonalization process. let x1 x2 so on till xn be a linearly independent set of vectors in an inner product space V, then there exists an orthogonal set of vectors y1 y2 up to yn. Means I have told you that converse of these statements is not true, but I know a process by which I can form orthogonal or orthonormal vectors. I am taking x1 x2 up to xn as Li set of vectors. Then there exists an orthogonal set of vectors such that inner product of x1 x2 so on till xi is equals to inner product of y1 y2 so on till yi for all I, where y1 is equals to x1. First orthogonal vector will be same as the first Li set of vectors, means equal to x1. Now second vector y2 is equals to x2 minus inner product of x2 with y1 divided by inner product of y1 and y1 into y1. Then y3 x3 minus inner product of x3 with y1, then inner product of x3 with y2, and so on. Yn minus 1. So note, so these are orthogonal vectors now. I have told you that y1 y2 up to yn are orthogonal set of vectors. Now to normalize these vectors means I want to make them orthonormal. So this process was called, or I can say the above construction is called if we normalize each yi, then we will get, so normalize means I will divide every vector y1 with its norm. y1 divided by norm of y1, y2 divided by norm of y2, and so on. Then it will be a orthonormal set. For example, and then this will be known as orthonormalization process. Now let us see example. बीटा 1 इक्वल टू 101, बीटा 2 इक्वल टू 10 - 1, बीटा 3 equal to 034 to obtain an orthonormal basis for P3R with the standard inner product. So firstly, alpha 1 will be equal to beta 1, but then it will be only orthogonal na? But I want orthonormal basis, means I will divide it by its norm 101. What will be norm of beta 1? Norm of beta 1 will be square root inner product of beta 1 with beta 1. 101. So this will be under root 1 plus 1, root 2. Now I need to find alpha 2. Alpha 2 will be my beta 1 minus inner product of beta 1. One second.
It should be beta 2.
Beta 2 minus beta 2 inner product with alpha 1 na? This alpha 1 divided by norm of alpha 1 into alpha 1. So beta 2 is 10 minus 1 minus inner product of beta 2 with alpha 1. So beta 2 alpha 1 inner product will be
0.
beta 2, one second, beta 2 was 10 minus 1 and alpha 1 is 101 by root 2. So 1 by root 2 minus 1 by root 2, yes, 0. So and I need to normalize this na. Simultaneously I need to normalize this. I can say like this that इसको ना थोड़ी सी नोटेशन की दिक्कत आ रही है, थोड़ा ढंग से लिखते हैं एक मिनट. देखो alpha 1 is equals to beta 1 means beta 1 was 101, but I need to normalize this. So on normalizing I can write it as gamma 1 beta 1 divided by norm of beta 1. So it will be 101 by root 2. Now I need to find alpha 2. Alpha 2 will be beta 2 or I can simply say it as gamma 2 and then I will normalize it and then I will write it as alpha 2. Beta 2 minus inner product of beta 2 with alpha 1 सब कुछ छोड़ो, नॉर्मली करते हैं फिर लास्ट में उसको नॉर्मलाइज कर देंगे, वो बेटर है. ये हैविंग मैं कंफ्यूज हो रही हूँ इतना इसमें। ठीक है। So alpha 2 is beta 2 minus inner product of beta 2 with alpha 1 divided by norm of alpha 1 into alpha 1. So beta 2 was 1 0 minus 1 and this inner product was 0. So alpha 2 is this. Alpha 3 will be beta 3 minus inner product of beta 3 with alpha 1 minus inner product of beta 3 with alpha 2 divided by norm of alpha 2 alpha 2. Beta 3 is 0 3 4 minus inner product of beta 3 0 3 4 with alpha 1 1 0 minus 1 divided by norm of alpha 1. It is root 2 1 0 1 minus inner product of beta 3 with alpha 2 and divided by norm of alpha 2. It is again root 2. Now let us solve this. 0 3 4 minus 1 by root 2. This is 0 plus 0 minus 4 minus 1 by root 2 again minus 4 alpha 1. It is plus 1 na? Alpha 1 plus 1. So this is plus 4. So this will be 0 3 4 minus 4 by root 2 1 0 1 plus 4 by root 2 1 0 minus 1 0 3 4 minus, if I take 4 by root 2 common, minus 1 0 minus 1 plus 1 0 minus 1 0 0 minus 2. So alpha 1 alpha 2 alpha 3. Now I will normalize this alpha 1 upon norm of alpha 1, or I can solve it further as 0 0 0 3 then 4 minus 8 by root 2. 4 minus 8 is 2 root 2 2. Is this clear? So alpha 1 is 101 divided by norm of alpha 1 root 2. Alpha 2 was 10 minus 1 divided by root 2. Alpha 3 is 0 3 2 divided by root 13. लास्ट वाले में इशू आया है, ये दोनों तो ठीक है, ये वाला रॉन्ग आया है, कुछ मिस्टेक करी मैंने।
3 6 नहीं आ रहा, जो लास्ट वाला वेक्टर है अल्फा 3, मेरा 0 3 6 आ रहा है।
0 1 0 दिया हुआ है।
-4 plus 0 minus 0 -4 minus 8. इसको वो भी करना नॉर्मलाइज।
0 3 4 minus in a bracket of this 1 0 1 4/√2 रैशनलाइज भी कर रहा हूँ तो भी 4√2/2 2√2 1 0 -1 4 -8/2√2 कहाँ मिस्टेक कर दी कुछ माइनस प्लस की मिस्टेक करी लग रही है ये तो बिल्कुल ठीक है 034 101 बुक में भी क्रॉस चेक कर लिया ये 2√2 ही आएगा ना 4/√2 को 2√2 लिख सकते हैं वहाँ ये लिखा हुआ है फिर जो नेक्स्ट वाला है नेक्स्ट वाला भी बिल्कुल सही है 2√2 फिर 034 030 आ रहा है ये वाला चेक करो 4 ये रहा 4/2 -1 0 -1 प्लस 1 0 -1 0 0 -2 -8/2 to 2√2 क्या गड़बड़ हो गई ये जो एंट्री है ना इसमें गड़बड़ हुई है कुछ मिली मिस्टेक बाकी पूरा ठीक है अगर इसको अगर इसको हम 4/√2 को 2√2 लिख दें साथ में 101 प्लस 2√2 1 0 -1 ये क्या बनेगा 0 0 -2√2 फिर -4√2 फिर भी गड़बड़ है ऐसे कैसे हो रही है गड़बड़
ये भी आ रही है वैल्यू तो 032 लास्ट में
030 आनी चाहिए
तो ये -4/√2 प्लस 4/√2 कहीं कैंसिल होना चाहिए कहीं पे साइनिंग में गड़बड़ हुई है
चलो इसको मैं वापस से करके देखूंगी आराम से हो जाएगा फिर ये वाला फिर कल बता दूंगी बस ये
मैं भी ट्राई करूंगी दोबारा से ना इसको पेपर
कभी कभी मिस्टेक नहीं दिखती ऐसे दोबारा करने से दिखेगी फिर 030 होगा यहाँ पे और फिर 030 norm of 030 will be square root 9 it will be
3 only
so this will be our required orthonormal basis and then we can divide it by 3 then it will be 0 1 0 na rest are same this is 0 1 0 next example I am giving this example to try 2 1 2 you can try this at home because it is lengthy na 410 x2 is 410 x3 is 3 1 -1 Here also you need to find the set of orthonormal bases. Now try this question. Assignment 5.2 question number 2. Now here V is a subspace of R cube spanned by U equal to 1, 1, 1 and V equal to 1, 1, minus 1. And you need to find the orthonormal basis. I am giving options also. One by root 3, 1 by root 3, 1 by root 3, 2 by 3, 2 by 3, minus 4 by 3, C part 1 by root 3, 1 by root 3, 1 by root 3, 1 by root 6, 1 by root 6, minus 2 by root 6, one by root 3, 1 by root 3, 1 by root 3, 2 by root 6, minus 1 by root 6, minus 1 by root 6. So do not apply that lengthy process. You need to check whether these two vectors are orthonormal or not.
Option C.
Reason?
The first two है उसमें तो वन बन ही नहीं रहा. The first वाले में second part में वन नहीं बनेगा तो वो नहीं हो सकता. B part में भी again वन नहीं बनेगा तो B भी cancel है. जो C part है उसमें फर्स्ट ऑप्शन और फर्स्ट और सेकंड दोनों में वन तो बन रहा है बट अगर मैं V का देखूं वेक्टर तो 1 1 minus 1 है. उससे मैंने रिलेट किया. जो मेन बेसिस वाला है U.
ठीक है. तो अब इसके बाद से कल वाली क्लास में करते हैं कंटिन्यू. ठीक है. इसके भी एग्जांपल्स हैं कुछ, वो देख लेना एक बार. इनर प्रोडक्ट स्पेस के जो आज का है उससे रिलेटेड प्रीवियस ईयर एक बार देख लेना, फिर कल डिस्कस भी कर लेंगे. ठीक है.
थैंक यू मैम.
यू आर वेलकम.